Okay, in this video I'm going to talk about limits and how to find out limits of certain function by applying certain rules. When we talk about limit is just the value of a function which it would have at some value of x. Let us say we have f of x defined as x squared minus a squared over x minus a. Now, is it possible for us to find out the value at x equal to a? Can we do that here? Well, we cannot, because in the current form, the value at x equal to a is not defined. Because at x equal to a, the denominator here goes to 0. And in math, we cannot divide by 0. You can have a 0 in the numerator but not in the denominator. So at x equal to a, we cannot just find the value. But what can we find? We can find the limit at x equal to a. And how do we do that? Well, first of all, we try to get rid of the 0 in the denominator. That's the main thing. In order to find the limit here, we need to get rid of the denominator, which is coming out to be 0. So is it possible for us to get rid of that? Let us see that. First we say that limit x approaches a f of x. Now we can write it like this as well. LT and limit is same. X approaches a. X square minus a square can be written as x minus a times x plus a over x minus a. I've applied the formula x minus a into x plus a for x square minus a square in the numerator. Now we can cancel these two out. So we are left with limit x approaches a x plus a. Now as we can see, the denominator is not 0 now. The 0 in the denominator is gone now. So I can plug in the value at x equal to a. So I'll get this value as 2a. So the value the function approaches at x equal to a is 2a. Same way, let us try another type of problem. Let's say we have limit x approaches infinity x square minus 1 over x cube minus x square plus 1. Now in these type of problems, what we call as rational functions, because in the numerator and the denominator you have a polynomial. These functions are known as rational functions. Well, basically what you have to do is you have to see what value of x we are approaching. Here we are saying that x approaches infinity. Now what does it mean by that? X approaches infinity. All it means is that x is getting a very large value. Now if x is getting a very large value, I can do some manipulation with the equation given to us, with the function given to us. Let us talk about the numerator. The numerator, I'm calling it as p of x, is given to be x square minus 1. Now if x is very very large, or x approaches infinity, it doesn't matter if we add or subtract 1 to it. Doesn't matter. It may be a constant value, but it does not matter, because x square is going to be so large it will not affect it. So I can say that as x approaches infinity, px is simply the higher degree term. The higher degree term is x square, so I'll say px is x square only. Leave out the rest of the terms. Even if we have lower degree terms involving x, we can leave them out, because x is so large, x square is going to dominate. This is called the dominating term. Now once we have this, we can apply the same to the denominator. The denominator we can write it as q of x, and the higher degree term in that thing is x cube. So now we have limit x approaches infinity, x square divided by x cube, which is limit x approaches infinity 1 over x. Now x is very large and you have 1 in the numerator. If you divide 1 by a very large number, you're going to get a very small number. Now how much small number we are talking about here?